Now, this one, we had started doing this and I think we did that one. Now we're supposed to, we'll try and do this one. So make sure I did tell you that when you're plotting atomic ionization energies, the first one with respect to the proton numbers. So the atomic number, and you have the first ionization energy of elements plotted. This is how the graph is going to look like. It's going to, across the period, it's going to look like this. It's going to go up when you're moving across the period. And remember, just a second. So across the period, this is how it's going to look like. And when the period changes, there's going to be a big drop. That's where the ionization energies are going to decrease all of a sudden, and the next period would start. So this graph that you're looking at, this particular graph over here, it's what portion of the periodic table is this graph from? Like, which group does A belong to?
Group 17.
Okay, so that's going to be group 17. And this one is going to be group 18. And all of a sudden, there's going to be a big drop. And you'll start all over at group 1 and then group 2 and so on. So he's saying that one of the elements reacts with hydrogen to form a covalent compound with the formula HX. So which group should it belong to?
Group 17.
So it is going to be group 17. It's going to be A, because a covalent compound like HCl is going to be formed by group 17 elements. These two are metals, so they're going to form metallic bonds. They're not going to have, they're not going to form covalent compounds. So that's the answer to this one. Is this clear, this one? Yes or no?
Yes, sir.
Yes, sir.
So then the next one is, you're given these elements, and this is across a period. And again, whenever there's a change in period, the whole thing starts all over again. So P and X are in the same period. Are P and X in the same period or not? Yes or no? Are
No.
they're not, because this is one period and this over here is the other period. So they belong to different periods. The general increase from Q to X is due to increasing atomic radius. So Q to X, this thing over here is talking about this general increase. Why do the ionization energies increase across the period? What's the reason for that? There are two factors. What are the two factors? Okay, so there is an increasing nuclear charge or proton numbers, and the other one is that the radius decreases. So the size of the atoms, they gradually decrease, which is probably written over here. You move across the period, you got more protons, and the atom becomes smaller and smaller because of the greater attraction of electrons. So that is also wrong, because he's saying that it's increasing atomic radius, which is wrong. The small decrease from R to S is due to decreased shielding. Where is R to S? So it's this one. It's the dip that happens at group 3. Why does the ionization energy at S at group 3 decrease? What's the reason for that? This one is
the electron is in the p orbital, which is a high energy orbital, so it's easier to take it out from there.
And the p orbital is more shaded, like you can kind of see over here. I'm not able to actually point it, or maybe I can. Just a second. So this one over here. If you look over here, it's going to be it's being removed from a p orbital, which is more shielded. So it becomes kind of easier to remove electrons from the group 13 element. So this one is also wrong because it's because of higher shielding. So the last one that's left is U2V. U2V is the group 6 thing. I mean, it's over here. So that's the dip at group 6, and that happens why? Because you've got a paired electron and they repel each other. So this is the reason for that at group 6. What happens is that the oxygen atom, which is over here, its p orbitals are now paired, especially this one. So since the p orbital is paired, it's easier to remove electrons. So there is more repulsion between them. So which is why the last one is the one that is correct. It's going to be option D. The small decrease is due to repulsion between paired electrons. TK, is this clear?
Yes.
Yes.
Sir, you checked number A as well. So
Which one?
A, you said that's correct as well.
Nee, I said A was wrong. Nee, I said I don't know why I marked it correct. We did discuss that they were in different periods. Is that clear?
Yeah. Yep.
I said then you
So sir,
have
in a graph, there are like two dips. One is because one electron is in the p orbital, and the second one is because spin pair repulsion.
yes. I mean, there's going to be across the period. There are going to be two dips. One is because of because the electron is in the p orbital, which is over here, and so there is more shielding. So all of a sudden, when you're moving from, if you look over here, if you look at the electronic configurations, when you move from the group 2 to group 3, all of a sudden the electron is now in a p orbital, which is further away, more shielded, and it's higher energy. And then there's a dip at group 6. Why? Because at group 15, the p orbitals all had one electron in them. And when you move to group 16, the p orbital now all of a sudden has 2 electrons. So they start repelling each other. So it becomes easier to remove electrons. So you have to remember both these reasons. Is that clear?
Yes, sir. Thank you.
I said then you have the properties of chlorine, bromine, and their compounds are compared. What property is so bromine? I mean, you've got chlorine and you've got bromine. So we'll just talk about ionization energy. What happens to the ionization energy down the group? Does it increase or decrease? So chlorine is going to have a higher ionization energy, smaller atom. Remember, a smaller atom is less shielded and the electron is closer to the nucleus. So it's more difficult to remove electrons. And this one is going to be lower. So which is why it can't be the first ionization energy thing would be wrong, because he's saying that the property must be smaller for chlorine compared to bromine. So I mean, this one is definitely wrong. The other ones are not related to ionization energies. But is this clear, this one?
Yes, sir.
Then this one. Which of the elements, sodium, magnesium, aluminum, silicon, I mean, it's across, I mean, this is the entire period 3. So has a lower, now this one, read this, has a lower first ionization energy than the preceding element in the periodic table. So which element is he talking about? Lower compared to the previous one. So which group is he talking about?
Third, 13 and 16.
So he's talking about 13 and 16, that it should be lower. You can see over here that this one is lower compared to the previous element, and 16 also it's lower compared to the previous one. So he's either talking about group 13 or he's talking about group 16. So 13 I think is aluminium and 16 is sulfur. So it's either one of them. And then he says it conducts electricity. So which one is the correct one?
Aluminium.
Aluminium.
So that leaves us with aluminium, and has a lower atomic radius than the last one. You don't even need that, but has a lower atomic radius than the preceding element in the periodic table. All of them have a lower atomic radius than the preceding element, because across the period, what happens? every atom, pick any atom, it's smaller than the previous element. Is that clear?
Yes.
Yes, sir.
So that is going to be, I mean, this one is going to be true for all elements in the period. Now this is successive ionization energy. Successive means you're constantly removing electrons from the same atom. So which group does this element belong to? When you,
Fifth,
which one?
five.
It's going to be group 5, because removing the first 5 electrons is kind of easy, but all of a sudden removing the 6th electron is difficult. So when you talk about successive ionization energies, this is what we are referring to, that you're removing electrons from the same atom. So removing the outer shell electrons, that's kind of easy, and removing the inner shells would be difficult. So whenever you'll have so whenever there's going to be a change in shell, there's going to be a big jump, because all of a sudden the electron is now closer to the atom. So which of the following influence the size of the ionization energy of an atom? So the amount of, I mean, that's basically, you have to list the factors. So charge in the nucleus, the amount of shielding of the inner electrons, and the distance between the outer electrons and the nucleus.
Sir, what's the answer for the
Sorry,
previous one?
previous one. So, I mean, this is group 5, right?
Yeah.
So what chloride would it form? Like if it's in group 5, how many bonds would it form?
3.
So it's going to form 3 bonds. So it's going to be
XL3. XCl3.
XCl3. And I mean, this is exactly the same question repeating. Now this one, I'll tell you about, I mean, you haven't studied melting points, so I'll just list the melting points. Like I'll list the order. Silicon has the highest melting point, followed by, I think, aluminium, then magnesium, and then phosphorus has the lowest melting point. So melting points increase in this way, right? And I'll also list, I'll also list the, I mean, this is across the period. So I'll also state the first ionization energy. Like first ionization energy, the way it's going to vary is it's going to be group 1, 2, dip at 3, then 4, 5, then 6, 7, and 8. So aluminium is over here, magnesium is here, and silicon is here, and then you have phosphorus over here. So I've listed both values. You've got melting points, silicon having the highest melting point and phosphorus having the lowest melting point. And I've also listed the first ionization energy of the elements, since they're moving across the period. So it's Mg, Al, Si, and then P. Now, both of these values are plotted against each other. So which one is the correct graph?
C.
Take a C. It's so the first, let's take it, that looks good. So the first one is I mean, let's focus on the first ionization energy. So phosphorus has the highest ionization energy, and the lowest one belongs to Al. So phosphorus has the highest, the lowest one belongs to Al, and followed by magnesium and then silicon. So the ionization energies on the y-axis, on the x-axis are plotted correctly. And then let's focus on the y-axis. The y-axis contains the melting points. So are the melting points ordered correctly or not? So you've got silicon having the highest melting point, followed by phosphorus having the lowest melting point, then followed by aluminium, and then there's magnesium. So both values are plotted correctly according to the axis. Okay, Ruba, that's clear. Is this clear to everyone?
Yes.
Yes, sir.
So next is you've got why is the second ionization energy of sodium larger than the second ionization. No, now this is not about first. Remember, we studied first ionization energies only. Now he's trying to compare the second ionization energy. So sodium is 11 protons, and then it's 2, 8, and then there's 1, right? So it's 2, 8, and followed by 1. And the other one is 12. So it's 2, 8, and 2. So tell me, what's the reason for the second ionization energy of sodium? I mean, this is sodium, and he's saying this is larger compared to magnesium. So why is sodium having a high ionization energy that's larger than magnesium, the second one? Yeah, what could be the reason for that?
A.
But say the thing is that A is obviously the obvious answer. I mean, it's pretty straightforward that the reason ionization energies are greater is because the attraction of the nucleus for the outer electron is obviously greater. So A is definitely the correct answer. So I mean, they didn't actually go into a lot of depth with this question. I mean, A is the obvious answer. But the reason for that is removing the second electron in sodium is being removed from an inner shell. Whereas in magnesium, the second electron is also removed from an outer shell, which is further away. So in the question, they didn't go into much detail. They just gave a very generic statement, which is obviously true. But if they had gone into a bit of depth, the second electron in sodium was removed from an inner shell. Is that clear?
Yes, sir.
Yes.
So then the next one is you've got which property of an atom does not affect its first ionization? So which property is not going to affect the ionization energy of an atom?
C.
Number of neutrons.
Neutrons, they don't attract anything. So why is the first ionization energy of aluminium less than that of magnesium? So what's the answer to that? Why is the first ionization energy of aluminium less than that of magnesium? I mean, it's the same. I mean, this is the same part where there's a dip. So the answer is, like, what are the two factors that are correct?
2 and 3.
The first one, the outer electron in aluminium is more shielded from the nuclear charge. Is that correct? I mean, this, if you look over here, I mean, aluminium is group 13, so the electron is being removed from a p orbital, right? So it's being removed from a p orbital. So if you look at a p orbital, it is more shielded. It's further away and there are more shells. Is that clear?
Yes.
Yes.
So it is more shielded, and so that is correct. And it is definitely, like, if I mean, aluminium's case, it's the outer shell would be 3s2 3p1, whereas in magnesium's case, the outer shell would just be 3s2. So it is going to be more shielded, and it is going to be higher energy. Would it be further from the nucleus?
Of course.
Now, what happens when you move across the period?
So it gets closer.
It
So
gets
the atomic radius decreases.
the atomic radius. So aluminium is somewhere. It's magnesium comes first, and then you have aluminium. So aluminium's electrons are actually closer to the nucleus. I did state further away, but it was further away compared to the 2s. I wasn't comparing it with some other atom. I was comparing it to its own orbitals. Do you get my point?
Oh, I see.
So I was just comparing that in aluminium's case, the 3p electrons would be further away compared to the 3s electrons, right? We weren't comparing it with Mg. So over here, he's just talking about in absolute terms, like, is aluminium's electron further from the nucleus compared to magnesium? No, it's not. It's going to be closer to the atom. But if you compare the electrons within its orbitals, then the 3p would be further away compared to the 3s. Is that clear?
Yes, sir.
Yeah.
So then it's this question again, and elements bj
So,
and
it's basically,
Mhm.
yes, sir. So it's basically because the element has more protons, so it attracts it even more. That's why the atomic radius decreases, yeah?
Yes. I mean, this one, yes. You've got more and more protons, so the electrons become closer to the nucleus.
All right.
But at group 13, because of slightly greater shielding, it kind of becomes, even though electrons are closer to the nucleus, but it kind of becomes easier to remove electrons. Because all of a sudden you've got more orbitals now at group 13. Now, which statement with this graph? B, J, and R are in group 18. So you've got B over here, you've got J over here, and you've got R over here. So are they in group 18?
Yes.
Okay, so they're obviously in group 18. Atoms of D and L contain 2 electrons in the outer shell. So D, which group is D in and which group is L in? I mean, these ones, they belong to?
Group 2.
So they belong to group 2, so they do have 2 electrons in the outer shells. And you've got G and O contain half LP orbitals. So G is which group? And O is, I think, the same group. It's the same one.
Group 15.
So it's group 15. So what's the electronic configuration of group 15? It's going to be S2 and
S2 and P3.
so it's going to be S2P3. So the P is going to be, the P subshell is going to be half filled. It's just going to have, so that's correct. They contain half filled. They contain half filled P subshells. Clear?
Yes.
Vishnu, can you explain 1 and 2?
1 and 2.
Yeah, the options for in the graph.
No, remember when you're moving across the period, the top is basically group 18, right?
Yes.
And the bottom is basically what? Group 1, right? So it's group 1, 2, and up till 18. So this one is the next period. So it's going to be the same. This one is going to be group 18, and this one is going to be group 1, right? So he was talking about BJ and R. So basically this one, and this one. The first period just has 2 elements. It's just hydrogen and helium. So you don't have much happening over there, but so they all belong to group 18. So which is why the first one is correct. Is that clear?
Okay.
And he was saying that there should be 2 electrons in the outer shell. So that's group 2. So D. So which one is group 2? This one is going to be group 2, and this one is going to be group 2. Because the bottom one is group 1, the next one is group 2, right?
Yes.
So group 2 elements D and L. I mean that is D, and this one is L. So they are group 2, which means they do have 2 electrons in the outer shell.
Okay. So all of them are correct, basically.
All of them are correct. You're not from now on. You're not going to get these types of questions. Maybe you would, but even in the previous up till 2021, you had 10 questions which had 1, 2, 3 options in them. You even got them in O levels as well. So they would give you a marking key. If they give you a question, they would give you a marking key which would have A, B, C, and D options. Like they'll tell you that what is A, like 1, 2, 3 are correct. B is 1, 2, C is 2, 3. So D is 1 only. So you might still get those questions. I mean, these types of questions, but they'll give you a key for deciding which options are correct. Like in the previous pattern, up till 2021, there were 10 questions for sure of 1, 2, 3 type questions, but now it's not going to be guaranteed. So this one, now this one is first thing, which group is X and Y from? Like which group is X in? And remember there's successive ionization energies.
Group 5.
And both of them?
Yes. Yeah. Both of them.
So both of them are group 5. So because there's going to be a big jump, so that means you're going into the inner shell all of a sudden when there's a huge increase. So 6th electron belongs to a place somewhere close to the nucleus. These are the outer shells. So they will both belong to group 5. So we know that. So what is the order? Which one is down the group? Which one is up the group? Is X above Y or is it the other way around? I mean, they both belong to group 5, but what is the order of those elements in group 5? Any idea?
Is Y above and X below?
Okay. And what's the reason? Why do you think Y is above X?
Because as you move down the group, the ionization energy decreases.
So exactly. So the ionization energies of Y are all larger. That means it's a smaller atom. That means it's harder to actually remove electrons from Y. So Y must be above X. So they belong to group 5 and Y is above X. That's one very important point. So let me just I don't have the periodic table, but you can figure out the order of Y and X. Just let me just my keyboard is not working. Just a second. Let me open. So Y is going to be above X. So in the pure table, where's the pure table? So you got group 15, and Y must be, so it must be this. I mean, they gave acetylene and antimony. So this one must be Y and this one must be X. So just remember Y is arsenic. And so here's the question. So Y must be arsenic and X must be antimony. They gave another, I mean, they gave it the other way around as well, just to confuse you. So is that clear? A lot of people, when they were attempting this question, they forgot this, that the order of the atoms also mattered in the answer. Is this clear?
Yes, sir.
Yes.
Okay. So next is we've got now this time he's plotting electronegativity of n across a period. That's NAMGAL. So you've got the first. I mean, I'm going to again the first ionization energy graph group 1, then group 2 dip, and then there's group 4. So it's NAMG, AL, and SI, right? And what happens to the electronegativity? Although we haven't studied this in this class, but electronegativity increases to the right. When you move to the right, the atoms, they have a greater tendency to gain electrons. So which graph do you think has both axes correctly plotted? This one is first ionization energy. This one is electronegativity. I mean, you can isolate the axis. Is the first ionization energy axis correct? Are they in the correct order? Like which
No.
one is going to have the highest? It's going to be silicon. Which one is going to be the lowest? That's going to be Na, right? So it's I mean that thing is correct. I mean these two are correct. The Mg and Al order is not correct because Mg is going to be the second highest. So it should have been Mg at this point. So I think this axis is correct because silicon is on the extreme right and Na, and so the order is, I mean, if you look over here, it's Na, then Al, then Mg, and then Si. So that one is correct. And which else is correct? It's I think this one is also correct. It's silicon. I mean, the ionization energy axis is correct. It's again not correct in this one. So the order is not correct. I mean, the ionization energy order was, according to the graph, it's going to be silicon having the highest and Na having the smallest. And if you look at the graph, then it's Al, and then Mg is higher than Al. So it's going to be this order. So is this clear? This axis, the first axis. So these two are wrong. Is this clear?
Yes.
Yes, sir.
Now let's look at the vertical axis. Like, who's going to be the most electronegative? It's going to be, I mean, silicon is here and Na is over here. So it's going to be silicon. Silicon is going to have the highest. I mean, this is the order across the period. So silicon is going to have the highest ionization energy. Silicon is over here. Then it's going to be Al, then it's going to be Mg, and then Na is going to have, it's going to be the least electronegative. So that order is correct over here. And that order is completely wrong over here. I mean, over here that they're saying that silicon is going to have the lowest ionization energy, which is wrong. Sorry, lowest electronegativity, that is wrong. And Na was having the greatest electronegativity, so that is wrong as well. So is this clear that option B is the correct option?
Yes, sir.
Yes.
Okay. And is this 100% clear? Because they're going to try and confuse you. It's not, I mean, the things are simple, the concepts are simple, but remember how to check if one axis is correct and the other axis is correct. I mean, you just isolate the two things. If you're looking at first ionization energy, just remember, just try and figure out, is this order over here, is it the correct order or not? And if you're trying to look at electronegativity, I mean, try and see if they've plotted this correctly. I mean, are there orders? I mean, the order of this thing, is this correct or not? If both of them come out to be correct, then that means that graph is correct. So next is, you've got consecutive elements X, Y, and Z are in period 3 of the pivot table. Element Y has the highest first ionization energy. So element Y, and remember they are consecutive elements. So I mean, you're moving across the period. So element Y has the highest first ionization energy. So if I go and have a look at the graph, so the middle one is going to have the highest ionization energy. So the middle one can be I think this one. I mean, Y could be group 15, because the middle one should be having more ionization energy compared to the ones on the right and left. Or it could be this one, or it could also be this one, right? Is that clear?
Yeah.
So they told us that X, Y, and Z, and the element that's right in the middle has the higher ionization energy. So it's either group 2 or group 15 or group 18. I don't think group 18 is an option in those answers. So it's either group 2 or group 15. So you've got I mean, X, Y, and Z. The middle one can be group 2, or it could be group 13, group 15. So those two are the options. So middle one is, so this one is correct. This one is wrong. So the competition is between A and, it's either A or D. And then he says that the middle one should have the lowest melting point of these three elements. Now that's kind of more related to inorganic chemistry, which we haven't done yet. But I'll tell you that the melting points, I mean, this is the graph for melting points. I'll just quickly draw the graph and we can relate that. So it's Na, then it's Mg, then Al, then silicon has a giant covalent structure. Then you've got phosphorus, sulfur, and chlorine, and then argon. So it's Na, Mg, Al. Now they were saying that the middle one, this Y, should have the lowest melting point. So that is not true for magnesium. Like if you pick magnesium doesn't have the lowest melting point because the compared to its neighbors, compared to X and Z. So that is going to be wrong. And if I pick phosphorus, so this is silicon, this is phosphorus, and this is sulfur. So phosphorus over here has a lower melting point compared to its neighbors on the right and left. So option D is going to be the correct one. So there were two things. One was that the middle element, they were consecutive elements X, Y, and Z. So the middle one must have the greater ionization energy compared to its neighbors. So for that, we were able to single it out and we were able to identify that it must have been group 2 or group 15.
Sir,
Yes.
we haven't done melting points, right?
No, we haven't done that.
Yeah.
Just to answer this question, this is why I wrote them down. We haven't done this. I mean, that's something that's something that you'll do in organic. So the first thing was the ionization energy part was you figured out that it must be either group 2 or it must be group 15. Is that clear? And the next part was that they were saying that the melting point of these three elements, the Y element must have the lowest melting point. So that singled it out till group 15. Like if you plot the melting points, then compared to its neighbors, P has a lower melting point. So this must be X and this must be Y and this must be Z. Hence the option is D and not A. Is that clear?
Yes, sir.
Yes.
And remember, these ionization energy questions, they're kind of tough. I mean, they are relatively tougher compared to, they're more tricky. I mean, for some reason, they make these questions very tricky. The other ones are kind of more straightforward, but these ones are always, I mean, the concept is very simple, but they always make it really tough. So you have to practice a lot. The only thing you can do is like 50% is question comprehension. So the only thing you could do is just practice more questions and single out those questions you're not able to understand. Make sure you get help on those. Now for the element sulfur, which pair of ionization? So he's talking about sulfur. So which pair of ionization energy has the largest difference? So sulfur is in group 6. So when would the jump happen if it's in group 6? After which ionization energy would there be a big jump and there's going to be a large difference? Like this one is kind of easy. You're removing electrons from sulfur. When would there all of a sudden be a very large increase in ionization energies?
5th and
6
6th.
and 7.
Okay, so it's going to be 6th and 7th. Like the first 6 electrons, they would all be kind of easy to remove, but all of a sudden the 7th electron would be from the inside. So that would be a lot harder to remove. Period, the successive ionization. So which group is this in?
Group
6.
So it's removing these electrons is easy. All of a sudden there's a jump. So that means these are outer electrons and that's in group 6. So you can just go open the periodic table and have a look which one is in group 6. You'll figure that out. Which one out of these is in group 4?
B.
B?
C.
C is group 4. The first 4 electrons, easy to remove, and all of a sudden there's this huge increase in ionization energy. So that's definitely group 4. And what's the electronic configuration of this element whose successive ionization energies are plotted? First thing, which group is this in?
Group 6.
6, yeah.
6.
Okay, so this is in group 6, so group 6 electronic configuration. What is the group 6 electronic configuration?
2s, 2p4.
Okay, so it's going to be S2P4. And this one is kind of, he's seeing the elements radon, francium, and radium have consecutive proton numbers in the periodic table. What is the order of, now the thing is, you're moving the consecutive proton numbers. So that's 1, 2, dip at 3, 4, 5, dip at 6, and then 7, and then 8, 17, and 18. Then all of a sudden you go back to group 1 next period and group 2. Now, the thing with this is they have consecutive proton numbers and the whole thing repeats after this. Radon is over here. Radon is a noble gas. It's actually Rn. And then you have francium, which is group 1. And then you have radium, which is group 2. And after group 2, there's going to be a dip and so on. The whole thing continues. So he's talking about this thing. So which one is the least endothermic? That's going to be francium. And which one is going to be most endothermic? That's going to be Rn. So A is going to be the correct option. So also remember when they're talking about consecutive proton numbers, they give a lot of questions on this transition that happens when you move from one period to the other period. Is this question clear?
Sir, what do you mean by least endothermic?
The endothermic hota hai na ki you're trying to remove electrons, right? Ionization energies are always endothermic. So most it always needs energy to remove electrons. So most endothermic means higher ionization energy. Clear hai?
Okay,
Okay.
sir.
Got it.
Yes, sir.
Chalo, theek hai. Chalo, let's continue. You can try and hand in the worksheet, the theory one, and then we might go over that once that is over. We'll try and do chemical bonding tomorrow now. Okay.
Okay, sir.
All right, sir.
Okay.
Allah Hafiz.
Take care. Allah Hafiz.